we introduce our project, the Smart Eco-Fan, an innovation designed for a cooler and greener future. Okay, so first of all, let's look at why this innovation is necessary. In our current climate, there is a rapidly increasing demand for cooling system. However, this demand comes with a heavy price, not just in terms of high electricity cost for the consumer, but also significantly higher energy consumption that impact our planet. This is where the Smart Eco-Fan comes in. As you can see on the slide, we have developed this an energy efficient and environmentally friendly cooling solution. It is not just a regular fan, it is an innovation system designed to provide optimal air circulation while consuming much less energy compared to traditional system. By integrating smart features in eco-friendly technology, our goal is threefold. First, to drastically reduce electricity usage. Second, to lower monthly cost for users. And most importantly, to promote long-term environmental sustainability.
To begin our presentation, let us address the component of needs by looking at the critical real-world problem that serve as the catalyst for our project. We have identified 3 interconnected challenges. First, we are experiencing extreme thermal discomfort driven by global climate change. The rapid rise in ambient indoor temperatures leads to severe heat accumulation within living spaces. From a biophysical perspective, this thermal stress causes immense physical discomfort and directly degrades human cognitive and physical productivity. Therefore, effective thermal regulation is a critical necessity. To mitigate this heat, current real-life applications rely heavily on standard grid-tied cooling systems like traditional air conditioners. This introduces our second problem, high energy consumption. These conventional systems demand massive electrical power to run their inefficient thermodynamic cycles, causing a severe spike in electricity grid load and introducing high financial burdens through expensive utility bills. This clear disparity creates an urgent demand for eco-friendly solutions. There is a crucial gap in the market for smart, sustainable, and energy-efficient cooling alternatives. We needed a system that minimizes energy waste and utilize renewable sources rather than draining the electrical grid. This provides a strong justification for engineering our Smart Eco-Fan, which perfectly balances human comfort with environmental sustainability. To address these pressing challenges, we engineered the Smart Eco-Fan as a sustainable solution. Let's proceed to the next slide to explore the core physics concept that power this system.
So now we are going to be looking at physics concept and application. There are 4 total, and we are going to be looking at it one by one. Firstly is rotational motion. The plate of the fan rotates in an anti-clockwise motion, which is in a fixed point, and it helps to cool down the room. The second one is angular velocity. The speed of the rotation depends on the temperature sensor of the fan, which means that if the room is hot, then the speed of the blade will go faster, while if the room is cold, then it will go slower. The third one is torque. The motor of the fan will convert solar energy to mechanical energy as it rotates. Then the last one is energy efficiency. For this Smart Eco-Fan, we will be using solar energy only that reduces electrical power. It will also for good reducing carbon footprint.
Moving on to slide 5, let's look at the real-life importance of our Smart Eco-Fan. We focus on 4 main areas: home, school, office, and factories. Firstly, home. For home, it helps to reduce monthly electricity bills significantly. The auto sensor adjusts the speed based on room temperature, so you do not have to change it manually. Second, school. In school, it creates a better learning environment for students. By improving air convention, it keeps the classroom cool and helps students to stay focused. Third, office. For office, this fan reduces the heavy usage of air conditioning. Comfortable staff are productive staff. It keeps the workspace stable and fresh. Fourth is factories. In factories, we need high motor torque to move air in large space. Our fan removes industrial waste heat efficiently and prevent work from getting heat stroke. In short, our design is very practical for daily use and industrial needs. Okay, next, I would like to walk you through the structural blueprint and mechanism of our Smart Eco-Fan design. As you can see from this sketch, this is a fully sustainable, automated cooler system powered entirely by renewable energy. Okay, let's start with how the system is powered. Okay, first, solar panel. Mount on the roof, it captures sunlight and convert it into clean electrical energy. Next is DC wires. It carries the raw power down to the solar controller, which regulates the current and protects the system from surges. Then DC cable. This safely delivers the regulated power directly to the fan. Okay, is its automation. First, temperature sensor. It constantly detects the ambient room temperature. Second, auto speed controller. This sensor sends data back to the controller to adjust the fan speed automatically. As shown in the legend of the bottom right, a cool temperature triggers low speed. Moderate temperature switches it to medium speed. And a hot temperature ramps it up to high speed, maximizing comfort based on real-time data. Lastly, for the hardware, we have a motor at the back driving the aerodynamics blades. These blades are specially engineered to maximize airflow while keeping energy consumption at an absolute minimum.
Operational workflow of our system. This diagram maps out exactly how the device applies core principles of rotational mechanics and thermal physics to achieve its objective. The mechanism operates through 6 progressive stages. The process begins with the electrical input. Here, solar energy from the PV panel is converted into electrical energy. This serves as the primary power input that initiates the entire electromechanical process. Moving into motor activation and torque generation, we observe the direct application of rotational mechanics as the electrical current flows through the motor and electromagnetic field is created, converting electrical energy into mechanical energy. This mechanism generates torque, the essential rotational force required to overcome the rotational inertia of the system. This torque directly resides in blade rotation. The rotational force causes the fan blades to accelerate until they achieve a specific angular velocity. In terms of practical application, the system acts dynamically. The angular velocity changes accordingly to the real-time ambient temperature, altering the blade speed automatically. Next, the system transitions from rotational mechanics into thermal physics through induced airflow. The physical work done by the spinning blade mechanically pushes air molecules forward. This process accelerates fluid motion in the room, establishing active force convection currents. We finally arrive at the observed outcome of our system, the cooling effect. By generating rapid fluid motion, the system drastically increases the rate of convective heat transfer from the environment. This thermal dissipation produces a highly efficient, self-regulating cooling solution.
So now we are going to be looking at equations and mechanism. So there are 2 total of the equation, but we are going to be looking at the torque equation first. It is worth noting that for our smart eco fan, we are going to be maximize the torque. The reason for this particular method is that we can have better airflow, and also when the solar energy is low or fluctuating, then it can still work efficiently. For example, during rainy days or during nighttime. So let's take a look. R times F times sine theta. So F here indicates force pushed from the motor that causes fan blades to rotate. R is radius, distance from the axis. It is also worth noting that longer blades of the fan means greater torque. Next is sine theta, effect of the angle of the applied force. And then the second equation is power equation, which is torque times angular velocity. The torque is for the motor, and the angular velocity that indicates how fast the blade rotates.
Okay, the next one is improved comfort. The impact. The system features more automation powered by closed-loop temperature sensor feedback. Okay, the result, this allows the fan to automatically self-adjust its speed based on real-time ambient room temperatures, providing users with completely hands-free, seamless comfort. Okay, lastly is a more sustainable design. Okay, the impact through renewable energy integration and eco-conscious engineering, we successfully minimize the overall carbon footprint. For the result, this provides a long-term eco-friendly cooling alternative that actively protects the environment and promotes green and sustainable.
So, to wrap things up, the smart ecofan is really about bridging that gap between physics theory and practical real-world application as seen in our conclusion. We have addressed the dual challenge of rising temperature and high energy consumption that we see everywhere, from our home to office and even factories. The core of the system is that it's intelligently optimized airflow based on the environment. It proves that you don't have to compromise. You can get maximum cooling comfort while keeping energy usage at a minimum. At the end of the day, it's a cost-effective and eco-friendly solution that significantly reduces both operational costs and our carbon for a sustainable future.